Hello learners, today we are going to solve a linear programming problem using the graphical method. So the problem given is maximization problem. Maximize z is equals to 3x plus 5y subject to the first constraint 2x plus 3y less than or equal to 12, x plus 5 less than or equals to 5, x comma y which is greater than or less than equal to 0. So first what we have to do is we have to convert the inequalities into equations. So the first constraint, which is 2x plus 3y, which is equals to 12. So when x is equals to 0, so we have to replace the 0 in the x place. 2 into 0 plus 3y is equals to 12. So this becomes 3y is equals to 12 and y is equals to 4. So we got first coordinate, that is 0 comma 4. So when x is equals to 0, y is 4. In the same way, when y is equals to 0, so constraint is 2x plus 3y is equals to 2. 2x plus 3 into 0 is equals to 12. So 2x is equals to 12. So x is equals to 6. So another coordinate we got when y is equals to 0, x is equals to 6. So from the first constraint we got two coordinates. So we got two coordinates. Now solving the second constraint. So the second constraint given is x plus 5 is equals to 5. Same procedure, when x is equals to 0, 0 plus y is equals to 5. So y is equals to 5. So we got the coordinate 0 comma 5, another coordinate. Now when y is equals to 0, x plus 5, y is equals to 5. So x plus 0 is equals to 5. So x is equals to 5. We got another coordinate, x is 5 and y is 0. As all the constraints are less than or equals to. So here if we observe in the problem, constraints 2x plus 3y less than or equal to 12 and x plus y less than or equal to 5. So when the constraints are less than or equal to, then the feasible region lies below the lines. Whatever the coordinates, using these coordinates we plot on the graph, no? So when you plot on the graph these coordinates, the feasible region will be always below that lines. So here I don't have the graph, but how we can take up. So here I am just drawing. So if I take from 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5 and 6. So first coordinate, see when x is equals to 0, y is equals to 4. When x is equals to 0, y is equals to 4. So here you will get 1 point. For this, here when y is equals to 0, x is equals to 6. So when y is equals to 0, x is equals to 6. Here we get one particular point. So if we draw a coordinate, so this is the first constraint, that is 2x plus 3y. So first constraint we got. Second constraint, when x is equals to 0, y is equals to 5. So when x is equals to 0, y is equals to 5. When y is equals to 0, x is equals to 5. So again let us draw. So here we will be getting one particular intersection. As it is less than, so the first constraint, so the feasible region will be here. The feasible region will be here. This is below the lines. So this is the exact point that should be 3, 2. Even we can calculate using manually also. Let me show you how we can calculate the intersection point. So intersection of the two lines. So intersection of the two lines. So we need to solve the first constraint and the second constraint. So the first constraint, what is the first constraint? 2x plus 3y is equals to 12. That is the first constraint. X plus y is equals to 5. That will be the second constraint. Okay. So here by solving second equation, that is x plus y is equals to 5, we get x is equals to 5 minus y. So this value we substitute in equation 1. So in this one. So the first one, what is that? 2x plus 3y is equals to 12. 2x plus 3y is equals to 12. So replacing the x value, 5 minus y plus 3y is equals to 12. So this will be 10 minus 2y plus 3y is equals to 12. So 3y minus 2y, 10 minus y, which is equals to 12. So by simplifying, y is equals to 12 minus 10, that is 2. Now we substitute this value in equation 2, because already we got x value. So x plus y is equals to 5. X plus 2 is equals to 5. X is equals to 5 minus 2, that is x is equals to 3. So y is equals to 2 and x is equals to 3. So here we got the corner point 3, 2. So this is how we calculate. Now evaluation, we have to evaluate the maximization function and we have to find out the optimal solution. So inserting evaluation, when it comes to the evaluation, here we have, so 4 coordinates already we have calculated and we have plotted on the graph. Now evaluation, the first coordinate, if we take 0, 0, so the function is z is equals to 3x plus 5y. So inserting the coordinates x and y. So 3 into 0 plus 5 into 0, it will be 0. The second coordinate we have 5, 0. So z is equals to 3x plus 5y. So 3 into 5 plus 5 into 0, it will be 15. And next coordinate we have 0, 4. So 3 into 0 plus 5 into 4, that will be 20. And we have 3 into 3 plus 5 into 2, that will be 9 plus 10, that is equals to 90. So maximum, here if we observe the value, so maximum lies in this particular coordinate. So the optimal solution z maximum is 20 at point 0, 4 when x is equals to 0 and y is equals to 4.